Hey, Miss Marek here. Gonna go over the review for your Unit 3 end of unit assessment on complex numbers and quadratic equations. All right, so let's get started here. On number 1, it says to write each expression in the form a plus bi. That just means when you write your answer, if you've got a real number in your answer, it should come first. And if you've got an imaginary number in your answer, it should come second. That's all that means. All right. So in the first couple problems, we're going to be adding and subtracting these complex numbers. So to do that, it's just a matter of combining the like terms. So on A, we've got like terms 4 and negative 2. Those are both real numbers. And then negative 3i and 6i. Those are both imaginary numbers. So we're just going to combine them. So we're actually going to be adding negative 2. So 4 plus negative 2 is 2. And then negative 3i plus 6i, that's going to be positive 3i because negative 3 plus 6 is 3. So that's A. Now on B, we're also going to combine like terms, but because it's a subtraction problem, I'm actually going to do the opposite. So I'm going to add the 2 and subtract the 6i. Okay? So now I've got like terms. The 4 plus 2, that's 2. And then the negative 3i minus 6i. Negative 3 minus 6 is negative 9, so minus 9i. The next one is also subtraction. So again, we're subtracting negative 2 plus 6i again. So subtracting the negative means you add the 2, but then you subtract the 6i. So we're just distributing that minus sign. Now we've got 7 plus 2. That adds up to 9. And then I is the same as 1i minus 6i. So 1 minus 6 is negative 5. So this is negative 5i or minus 5i. The next two problems are multiplication. And so when we multiply, we use a box. So for this one, I have 4 minus 3i and then negative 2 plus 6i. So multiply inside. 4 times negative 2 is negative 8. 4 times 6i is 24i. And on the bottom row, negative 3i times negative 2 is 6i. And negative 3i times 6i is negative 18i squared. And then I squared is equal to negative 1. So that becomes positive 18. So now the real numbers I add together are negative 8 and 18. They add up to 10. And then the imaginary numbers, 24i and 6i, they add up to 30i. And that's the answer. Okay, E. It's a similar problem. So I'm going to set up a box. And I'll put the 7 plus I and negative 2 plus 6i. All right, so 7 times negative 2 is negative 14. 7 times 6i is 42i. I times negative 2 is negative 2i. And I times 6i is 6i squared. And again, because I squared is equal to negative 1, 6 times negative 1 is negative 6. So the real numbers to add together, negative 14 and negative 6, they make negative 20 altogether. And 42i plus negative 2i is 40i. Negative 20 plus 40i. All right. Number 25, we talked yesterday about how you can use like that little diagram where you have your real number line, 1 and negative 1, and then your imaginary number line, I and negative I. And then just remembering that right here is where we start when we count the powers, because this is 1 is equal to I to the 0. So it takes 1, 2, 3, 4, a power of 4 to get all the way around. And so for I to the 25th, I'd be able to go around 6 whole times, because I to the 24th, right? I to the 24th. So since 24 is divisible by 4, 24 divided by 4 is 6, then I could go like 6 whole laps and then plus 1 more. So I go around 6 times, I get here, that'd be 24, and then to the 25th lands up here at I. So I to the 25th is just equal to I. Okay, and then I'm going to do the same thing with I to the 46. I know 40 is a power or a multiple of 4, so I'm just going to use that. And 46 is 40 plus 6. So 10 laps would get me I to the 40th right here. So this would be 40, 41, 42, 43, 44, 45, 46 lands over here. I to the 46 is equal to negative 1. All right, moving right along. Get my calculator. In the next section, now we're going to start looking at some quadratic equations. All right. So the key for number 2 is to see, it says how many real solutions does x squared plus 2x plus 15 equals 0 have? Explain how you know without solving it all the way. So on Friday last week, we focused on the discriminant. And the discriminant would allow us to know how many solutions a function or an equation has and whether they're real or complex. So we're going to use just this part of the quadratic formula. The equation is already equal to 0. So that means A is 1, B is 2, and C is 15. So I'm going to calculate 2 squared minus 4 times 1 times 15. And I'm going to put that all into my calculator at one time. Let's see, where's a good spot? Oh, right there. Okay, so 2 squared minus 4 times 1 times 15. So b squared minus 4ac, negative 56. So since this is negative 56, there are no real solutions. Now, if it was positive 56, there would be 2 real solutions. And if it was 0, there would be 1 real solution. Okay, so we talked about that. That's in lesson 19. All right, number 3, select all the solutions to x minus 3 squared equals negative 25. So I know I'm going to have to square root. So I'm going to square root and get x minus 3. And then negative 25 has a positive and negative square root. In fact, the square root of negative 25 is 5i. Okay, so now what I want to do to get x by itself is add over the 3. And I get x equals 3 plus or minus 5i. So here I see 3 plus 5i. That's a correct answer choice. And here I see 3 minus 5i. That is a correct answer choice. And that is it. All right. In number 4, we've got two students who are both trying to solve this equation. Nevaeh is solving by completing the square, and Lily is solving with the quadratic formula. So we basically just have to finish their work. So Lily gets stuck right here because she knows she has to square root, but that's a negative number. So we're going to go ahead and finish. X minus 4 equals the positive and negative square root of negative 9. And so just like the problem we did above, the square root of negative 9 is equal to 3i. So square root of 9 is 3, and then the square root of negative 9 is 3i. So now we add over the 4, and we get x equals 4 plus or minus 3i. Okay? Now over here, let's see here. So this is Lily's work, and Lily has some errors in her work. So let's look at this initially. So here's our equation. It's already set equal to 0. So I know A is equal to 1, B negative 8, and C 25. Okay? So I'm just going to double check at first. So here's the formula. Now right here, this should say negative 8. So kind of that's a problem to begin with. So we should negative 8. This step should change to 8 because two negatives make it positive. And then I think the rest is okay. B squared minus 4ac over 2a. So the rest is okay. And she did a good job remembering to put the negative 8 in parentheses. So minus 4 times, times 1 times 25. Oopsies. Now the whole thing is divided by 2 times 1. Okay, so that's where she made her first mistake. So I'm just going to finish the problem from here. So now, after I do some simplifying, I have 8 plus or minus the square root. And I think this step is good because this is 64 and this is 100. But what happens here a lot of times is that we get messed up at that particular spot. And so I always recommend just starting with b squared and then put in the entire discriminant, the whole b squared minus 4ac. So it is negative 36. So that step is correct, negative 36. And now we have to divide by 2 times 1, which is 2. Okay? So here's where we have the problem. She went from negative 36, or the square root of negative 36, to just 6. But the square root of negative 36 isn't 6. It's 6i. Okay? So from this point, she can say x equals 8 divided by 2 plus or minus 6i divided by 2. And now we can simplify even a little bit more. So 8 divided by 2 is 4. And then 6i, so plus or minus, 6i divided by 2 is 3i. So this is the final solution. And if you look on the other side, those are the same. Sometimes when you use the quadratic formula, it doesn't look exactly the same compared to using completing the square, but in this example it did. All right, so we've got some equations to solve on the back side. There they are. And you can decide if you want to use the quadratic formula or completing the square. Now, this first one looks a little bit different. We talked about this at the beginning of the unit. This is already factored, and when you multiply two numbers together and get an answer of 0, then either 10x minus 10, the first factor, equals 0, or the second factor, x plus 3, equals 0. So you just have to solve these individually. Then divide. So I added the 10 over. Now I'm dividing by the 10 next to x. And I got x equals 1. The other one's pretty easy to solve. You just subtract the 3 and get x equals negative 3. So x equals negative 3 and 1. Okay. All right, the next problem, I don't know if I can factor it. Oh, actually, you could factor it, or you could complete the square. I'm going to go ahead and complete this. No, I think I'm actually going to factor it, because there are factors of negative 50 that add up to negative 5, negative 10, and positive 5. So they multiply to negative 50, and they add to negative 5. X minus 10 times x plus 5 equals 0. And so again, it's kind of the same idea as over here. If x minus 10 equals 0, then x is 10. And if x plus 5 equals 0, then x is negative 5. Okay, so we could have done something different, but it was easy to factor that. Okay, I will go over completing the square for C though. So the first thing I'm going to do is figure out what value completes the square. So I'm just going to look at x squared plus 14x to determine that. So x squared plus 14x, I'm going to put this into the box with the x squared right there. And for the 14x, I'm going to put 7x on both of the diagonals, exactly half of 14x. And so x squared is x times x, and then we need a 7 here and down here. And then 7 times 7 is 49. So 49 is that number that completes the square. So instead of a minus 38 here, I need it to say plus 49. So what I'm going to do is add the 38 to both sides, and then also add the 49 to both sides. Because here, negative 38 plus 38 is 0, and 0 plus 49 is 49. So that'll get me a perfect square trinomial. And then I'm going to use my calculator for 38 plus 49. I get 87. Okay? And so now I'm going to rewrite the left side in factored form using x plus 7 times x plus 7, which is x plus 7 squared. And now we're almost done. So if x plus 7 squared equals 87, then x plus 7 equals the positive and negative square root of 87. Now I just subtract the 7 to move it over, and I end with x equals negative 7 plus or minus the square root of 87. Oops. Final answer. All right, on D, I see a number in front of the x squared, so I'm going to use the quadratic formula. The equation is already set equal to 0, so I know A is 4, B is 8, C is 5. So x equals negative B, negative 4, plus or minus. Since I have the quadratic formula on that little note card from the other day, I'm just going to put it here. I'm just following the formula. Oh, and I already made a mistake. So B was actually 8. So negative B is not negative 4, it's negative 8. Plus or minus the square root of B squared, so 8 squared, minus 4 times A, which is 4, and C, which is 5, all over 2A. 2A, so 2 times 4. Okay? Now that I've got them plugged in, I'm just going to do some cleanup. Negative 8, plus or minus, let's see here. I'm going to go ahead and put the square root symbol there, and then I'm going to calculate. There we go. I'm going to calculate 8 squared minus 4 times 4 times 5. Negative 16. Okay, we're going to have some complex solutions because we have the square root of a negative number over 2 times 4 is 8. So there's quite a bit of simplifying to do now. We're going to divide both of these terms by the 8. So negative 8 divided by 8 is negative 1. And then plus and minus. The square root of negative 16 is 4i, right? Because the square root of 16 is 4, so the square root of negative 16 is 4i. And then I have to also divide that by 8. And then one tiny little detail is that this can be simplified because 4 divides into 8. So you can write your final answer as negative 1 plus or minus. So 4 goes into itself once and into 8 twice. So that would just be 1 times I, which is I, over 2. So that would be all the way simplified there. All right, for E, I'm also going to use the quadratic formula. There it is. But in order to use the quadratic formula, I have to subtract the 12x, and it's just going to go right in the middle of those two. So 2x squared minus 12x plus 10 equals 0. And now that I have 0, 0's a big deal, I can say what A, B, and C are. Okay, and I'm just going to put a box around that to draw attention to it. Okay, so x equals negative b. B is already negative, so I'm going to make it positive. The square root of b squared minus 4 times a times c all over 2 times a. All right, so I have 12 plus and minus the square root Now I have to calculate negative 12 squared minus 4 times 2 times 10 is 64. And 2 times 2 is 4. Now, the square root of 64 is 8. These are going to be real solutions. So we have to find 12 plus 8 divided by 4 and 12 minus 8 divided by 4. Okay, so when we get something that has a whole number square root, we're going to keep on calculating. So 12 plus 8 is 20, and 20 divided by 4 is 5. 12 minus 8 is 4, and 4 divided by 4 is 1. So final answer, x equals 1 and 5. All right. For F, let's see here. Could you factor that? I don't think so. Could you use the quadratic formula? Sure. Could I complete the square? Absolutely. I'm going to do that. I'm going to complete the square. It's not going to be beautiful, but it's okay. So first, I'm going to figure out what value, because see, I don't have a constant here. There's a negative 20 over there, but that's okay. I can leave it there. Completing the square, you don't have to be equal to 0 first. You just want to make sure all your x's are on one side. If this is just a number, it's fine, because eventually you're going to move it over there anyways. So for x squared, that goes there. And then to break apart the 1x, we would just do like half. So 0.5x and 0.5x, which gives us x and 0.5 and 0.5. So 0.5 times 0.5 is 0.25. So 0.25 is the number that completes the square. So I'm going to add it here and here. So I have x squared plus x plus 0.25 equals, now just be careful here, negative 20 plus 0.25 should be negative 19.75. Negative 20 plus 0.25 is, out of the glare, yeah, negative 19.75. So negative 19.75, okay? And so I've already completed the square. I'm going to write the left side in factored form as x plus 0.5 squared, since it's on both sides, equals negative 19.75. Now I know I'm going to have complex solutions. And just because I'm not familiar with that number, I'm going to double check. Does it have a whole number square root? I feel like it doesn't, but oh shoot. Okay. Your calculator doesn't know how to do non-real answers. So to get around that, I'm just going to get rid of the negative sign here. And then see, does that, oh, it does not have a whole number square root. So that means we're still going to square root both sides of the equation. X plus 0.5 equals the positive and negative square root of 19.75. And now when we subtract the 0.5 from both sides, we get x equals the negative, because that's 0, right? So negative 0.5, negative 0.5, plus or minus, I forgot to put the negative on that, right? It should stay negative, plus or minus the square root of positive 19.75 with an I after it. So it is a complex solution. And then that negative here makes us have an I at the end of our answer. All right, we've made it to the last question. Okay, so we have this graph of 3x squared minus 18x plus 15. And so we want to determine values that would cause the equation to have two real solutions and then two non-real solutions. So for let's talk about the real solutions. Any time where you cross the graph in two places, you're going to have real solutions. So this graph is counting by twos, right? 2, 4, 6, 8, 10. So I just made that green line at 4. So if this was equal to 4, there'd be two real solutions in each of those places. Okay? Even like negative 4 would have two real solutions, and so would negative 8, two real solutions. But negative 12 would have exactly one real solution because that's where the vertex is. But anything after negative 12, like maybe negative 14, would have two non-real solutions, right? If it doesn't touch, then it's going to have complex or non-real solutions. So there are, I meant 14. There are lots of possibilities for values you can put on the line. But in order to get real solutions in general, m has to be greater than negative 12. It can't equal negative 12 because negative 12 just has one solution, but anything above that will have two real solutions. Okay? And then the other way around, anything below negative 12 will have two non-real solutions. So you just have to have a number more than negative 12 for A and less than negative 12 for B. But if you said m equals negative 12, then you only have one real solution. So this should not go on any line, because right here, see how there's just one, okay? Okay, so that is the end of the review and also the end of this video. Good luck.